Okay, so now, first of all, have anyone any questions about sort of the structural stuff so far before we get into the actual assignment topic? All right.
Well, we got
Daniel, yes.
notebooks. So we got notebooks. We're just gonna pick stuff, right? And then we're gonna understand the whole thing. That's what I understand the lab
Yeah,
is
yeah. So
about,
the
right?
note, yeah. So the notebook are for the first part of the assignment. They serve as sort of like a head start for
Yeah.
it to like save you from some of the stuff that is not really like the goal of the assignment. The second part, however, is sort of free coding, partially because we wanted to give you more freedom for like how you want to implement it, but also there are a bunch of example implementations for it online. But we'll come to that when we talk about that part.
Oh,
Um,
so both
but yes, for the first
notepads are for the first one. Sorry.
yes, yes, yes. Yeah, I'll talk about that as well when I go through the stuff now.
Okay,
So
fine.
so we have part one, which is following up on this fundamentals of machine learning and artificial networks that you had in the very first lectures. So for the first actual task, you'll be working with the nearest neighbor algorithm and with a simple data set. So you're going to use this MNIST data set, which is a data set of hand-drawn digits like 0, 1, 2, 3, 4, and so on. There's 60,000 images of them with all the different numbers equally balanced. And then you're supposed to use k nearest neighbors classifier to detect from an image which number is it supposed to be. This is quite like a classic sort of first machine learning task, and in the notebook that is here, downloaded from Canvas, you get like some sort of examples, like it loads the dataset for you, so you don't need to like go find the download dataset yourself. It's like already getting downloaded from a popular Python library for machine learning in here, and then it also shows you some of the images as an example and gives you some basic functions to get started. So this is recommended either as like inspiration or to just use this directly to continue with your own code. And then Evgeny also linked this tutorial here, pre-processing for deep learning. Don't get spooked by this annoying banner. It's not actually a paywall. It just is annoying for like 5 seconds, and then we can click it away. But content-wise, this is also quite a good explanation for sort of more the mathematic perspective of the basics, but also with code examples. A bit confused, like what is all this about? This is a good read. And then, yes, you are supposed to first just run sort of the example code, and then you extend it to use the L2 norm. You try to fix the low accuracy, and so on and so on.
Maybe
If you have
hi,
specific questions about these.
it's Evgeny here. Just want maybe you want to add a small comment on this bug stuff. I can give maybe a hint here. So a hint is already given, but just to maybe save your time. So when you check the distances, pay attention to the types of data used in the calculation. So that's what I want to add as an extra hint. So the problem is in the combination, combination of calculations and the type used.
Thank you. Nishant has a question.
Yep. For the point one, where we run that pre-processing for deep learning, we create another Jupyter notebook where we show all the steps we ran, referring to that blog.
I think you can extend the existing one.
Existing one, okay. Yeah.
Yeah, it doesn't have to be a separate one. You can put it all in one if you want. Doesn't matter too much in the end. So, Farouk.
Yeah, step one again. So in step one, we just review the notebook. We will do nothing.
Well, step one is reviewing this tutorial, pre-processing for deep learning on the separate website. And you want to do that in code yourself, but there's code examples there, so it's not all from scratch completely. And then the second point here is running the notebook that you find on Canvas, this one.
Yeah, 2, 3, 4, and 5, I think clear, but for
you're
number
supposed
one,
to answer.
Yeah, because it's written here, you need to demonstrate the notebook with all the steps.
Yeah, it means all the steps from the tutorial.
So it's exactly the tutorial we follow, and we run that and see how it works and read through the tutorial, right? There's no changes in what they have given.
The tutorial...
No, guys, wait. I think maybe you should take a time and reflect on what's written. So there is no inconsistency whatsoever. The code, so you take the MNIST data set, MNIST, and follow the tutorial and do all the steps. In the tutorial, there is no MNIST. So just think about it. Okay, so there is no notebook for this, so it means that you need to extend it. So you follow the steps, but apply it to MNIST dataset, and it is written in item 1.
So just have a look at the tutorial that's linked in the assignment. It will be more clear when you just sort of read through the pre-processing steps there, and the pre-processing steps from the assignment, from the tutorial, are the steps that are meant in this with all steps. So okay, yes, that should be all for this first task. Second task. Now we're getting more into artificial neural networks. Quick question to the room. Have you used neural networks before in Python with like libraries like Keras, TensorFlow, or PyTorch? You could write in the chat if you have.
It's good for us to know. Yeah, it's very good for us to know.
Okay, so it looks like very little to no experience in the group. Yeah, so something that's maybe good to know for you guys, you will sort of see it from the notebooks as well. But for understanding purposes, it can be good to implement the networks yourself, like we have in the notebook for the second task. We have various like classes and functions in Python here that construct the network sort of manually. But in practical use, which we will have in the following assignments, we usually don't do the network sort of fully in steps as here. We use Python libraries that are popular for these purposes, because the libraries are heavily optimized, and if you run your code in there instead of sort of handmade like this, it will just be a lot faster. And since you probably don't all have like strong computers with external GPUs, dedicated GPUs, this will come in very handy. That this is not the only way to do neural networks, but for this task, it's very good to do it this way, since it lets you have a closer look at how things actually work in the network. Oops. Yes, so for task 2, you start with having a look at that notebook that I just showed, the code in and backprop task. It's the second notebook that's linked in the canvas. And then we have a mix of questions and coding exercises for you here. You should be able to explain several things that are integral to the content of that notebook. You might get quizzed on these specifically in the assessment, so make sure you don't just write it in the report and then sort of forget about it. Like try to learn it, and then make some changes to the notebook with different parameters, and talk about what kind of changes that causes in the results. And that's task 2 in a nutshell. Then we get sort of started with the actual secure AI part of the course for part 2 of the assignment. So it's not over here. There's an assignment continues on the next page. We got part 2 of the assignment, which is sort of the more interesting, but probably also the more challenging part, where we try to implement a specific attack that got famous a couple years back. The so-called one-pixel attack. You hopefully have already looked at the paper that was linked for this, but in case you haven't, this attack is specifically aimed at convolutional networks, which are often used for image classification. And the idea was, can we trick the classifier into giving the wrong prediction for an image by changing the input slightly? And this has been shown before this paper. This was already shown in various ways that you can fool them quite effectively. But this paper was sort of serving as an example, not necessarily as like the most effective attack to be ever made, but rather with even just changing one single pixel and no more, we can already trick the model somewhat reliably. And to sort of showcase this fragility of the networks when it comes to classification, we want you to implement this attack yourself using Python to see for yourself how well it works, and talk a bit about what you see happening. So here there's no starter notebook to give you more room for implementation. There are also, as I mentioned to an earlier question, there are several example implementations online. There might even be an implementation from the paper authors themselves. When it comes to these, of course you can look at them for inspiration if you don't know how to start or how to work on a specific part of the pipeline that is described in the paper. But no matter how much inspiration you take, don't just copy like full chunks of code from stuff you see online into your submission. It's pretty easy for us to check if you do, and it will count as a fail. So you can look at what's being done online. You can look at what other people do, but please don't just copy over the code, because you are supposed to make your own implementation to properly understand how this works. And to save you sort of some effort here, the idea is that you will use the well-known ResNet 18 model as the model that you will be attacking, and then the Cypher 10 dataset, which is a dataset of photographs of various things in 10 different classes, and are easily available through common libraries. You don't need to go download these, you don't need to code the model yourself. You don't need to download this dataset from some random website. Ideally, you use the library PyTorch combined with the companion library TorchVision, which are libraries specifically aimed at machine learning in Python and image classification tasks, because they have the model and the dataset available through the library. So you don't need to make any sort of external downloads. You don't need to fill with any files. You can just put 2 or 3 simple lines in your code that will download the model and the data for you, so you can work with them right away. And then when it comes to actually implementing the attack, I strongly recommend you that you look at the paper again in the methodology section where they explain sort of step by step how they construct the attack. But the core things that you will definitely need is some sort of mutation strategy. You will need some fitness function to train your attack on making the right choices, and you will need some sort of constraint handling. With constraint handling, I mean you need to handle the image sizes to make sure everything's sort of in the right same size. The data set is already pretty uniform, but still you should make sure that your attack doesn't like trip up if something is like a slightly different size and so on. And also make sure you check whether you're working with color images or if you want to put them in grayscale and such things. And there's a question. How much can implementations differ? It is a specified attack wouldn't follow a pretty specific algorithm. Yes, it is fairly specific, but you can still, let's say you find like a description that is like basically like one sentence for every function that you would need to write in code. That's like pretty specific instruction-wise, but I would wager to guess that if we have 10 people in the course write their own individual code based on these like sentence by sentence instructions, the code would still look different. So like don't stress about accidentally like creating code or something. And it's not like if one line in your code matches a line we saw somewhere else that you like immediately fail the assignment. Like it's not that bad. It's mostly about don't go to tutorial, copy half the code, you know, and like write your own 2 lines at the bottom and call it a day. That's what we don't want you to do. But when you work on it yourself, don't stress about accidentally like recreating the code from somewhere else. It's okay. So once you've got your code running for the attack, we want you to do some evaluation of how well it's actually doing in a specific format. So specifically, try to run some sort of like simple experiments to see what percentage of images can be successfully attacked, which means when you try to manipulate an image with the attack, you send it to the target model, and then you see, does the model get confused by a change? And then just send a bunch of images and see, okay, how many of them can we get the model to get wrong? Because it will probably not be 100%, but it will also be a lot more than 0%. You don't have to get like the same success rate as the original paper. It's okay if your version does not do like equally as well. So don't stress about that either. But I want to evaluate how well your solution is working and think a bit like, okay, what about this is maybe like holding it back, or why is it working? Maybe if it's working very well, why is it working so well, you know? Also try to have a look at the efficiency of your code, like how many iterations of the attack code do you need to prepare a successful manipulated image. Here again, it's more about considering these things by testing how long it takes. You don't have to like optimize to a crazy level. It's not about getting as few iterations possible. That's of course nice if you can, but it's not the focus here. It's just try to take this into account and have a look once your solution is going. Have a look, okay, how long does it actually take? How sort of efficient is it? And then lastly, when you've tested a bunch of different images, try to have a look over like the different kinds of images. Are maybe some of them more easy to like get the model to get confused on than others? Maybe certain like colors or certain patterns in the image, or just certain objects in the image get like confused often, and try to see if you can find any patterns like this and write about that. There's another question. The oral assessment. No, we have changed it. I mentioned this at the very beginning.
I think maybe in the calendar it's still not changed yet. I don't know. Is it in the calendar?
Evgeny, did you change the time edit, right?
Please say again.
Okay. Did you change the date for the assessments?
The time edit
edit?
should be adjusted. Since I can use this opportunity and say that I haven't adjusted the doc file, but there will be changes because I mean this is a new course in this settings with we have in which we have this many students. And there will be changes, so please monitor Discord. I can verbally say that that all people in Skellefteå, so physically located in Skellefteå, they will assess the labs to me personally, so on the site. And I am currently awaiting action from the administration, from our educational administration, to sort you out in different sections in Canvas so that I have better logistics there. And when this is done, I will divide you into the groups for assessments. The groups are not the groups you work with, so this is important. So you will be divided into groups randomly, into groups of 4. And I also reconsidered the previous idea. So we also will assign fixed slots to different groups. So this is to ensure smooth evaluation. So, but saying that, so you will see more announcements. Well, by email. I also will duplicate these important announcements by email, but also in Discord. If you have any questions, so please ask now.
Evgen, I did check the calendar, and it's still a lab session on Friday, and not on Tuesday.
Then I need to call our schedule office. No assessments on Friday. So it is Tuesday. It will be Tuesdays.
Yeah.
Will we get to choose the timings?
Deadline also.
Say again. It was an interfering question. Sorry. The last one who asked, what was it?
Yeah, maybe I can go. Will we get to choose the timings for the Tuesday? No. You will divide it into the slots, right?
Yes.
Okay.
Wondering also if the whole group will complete in 50. Yes, that's it. I can tell you how I mean the point with the assessment is to really I mean we call it what is the English word for this expression? I mean we do stick proof. I mean when random
spot check.
Yes.
Checking.
A random checking. So basically, it's not a formal exam. So the idea is that you do the labs, and while doing the labs, so as you see, they are very comprehensive. I mean, detailed and and covers lots of materials. So connected to what we talked on the theory a week. And again, my true hope is that you learn a lot of things while doing these labs, and I'm sure you will. And that's why, so I allow you to work in groups as you please, to share the load. But again, the important thing is that each and every one of you understands all the points. And the point with the assessment is to quickly check your understanding. So normally, by the end of the lab, you should have, by default, have a good understanding of the material. So what will happen during this 15 or somewhat 15, sometimes less assessment slot? So you will turn up in a group of 4. I will bring you to, or we bring you to a breakout room, and then say, okay, so person A, so share your screen, go to part of the notebook, explain what's happening there. So, or maybe the tasks will be given to all four in the beginning of the slot, and then the first one who answers. So it will be this kind of ping pong, very quick question response session. So within 15 minutes, we will get an understanding whether, say, a hypothetical person who uh, didn't follow all the steps and don't know the details of the intermediate steps will basically expose it to us. And then in this case, what happens? So now, I mean, it's not the end of the world. We say, okay, so go and fix this part, and then we take it next time. That's so let me just again. So there is so you. That's not how it even was announced in the beginning. So you're free to choose the names. That's correct. But for the assessment, you will come in random groups, and that also will ensure us that you do not have people working with you in a group, kind of interfering with your answers, so to say. And believe me,
Yeah,
I
to be
mean,
clear, the group
that's
that you
not.
are info.
Yeah, just Tim, one more last thing. I mean, that's not the first time we do this in this format. So I mean, it works. It works. It's not exhaustive for students, given that you know what needs to be done in each step. So Tim.
Yes. So as a quick sort of summary point, so the groups that you work in for like preparing the assignment like over the week, those are the groups you choose yourself, but they're not the same groups that we use in the assessment. In the assessment, you get assigned a randomly created group that's not the same for people that you work with. And there, in that random group, you get assessed. And that's mostly because we don't have enough time to ask each of you in a Zoom room separately. And as Evgeny said, this is mostly about finding out whether you properly worked on the assignment. We of course don't have enough time to go over the full assignment with everyone in 15 minutes.
And again,
but of course you also want to know which part you get quizzed on. So be sure to prepare sort of holistically. And worst case, you will have a follow-up assessment.
But over again, so it's not our goal to fail you. I mean, it's our goal that you actually follow the steps. And as you see, so the description of the labs are very kind of, step by step. I mean, it's complex. I understand. And I also know, see, I mean, that maybe you have different backgrounds. And on the other hand, so this is, again, so we learn as you learn. So we shall see, but I mean, don't be super stressed about assessment. Just be sure that you have understanding of all these steps. So we have a hand rising from Natasha.
Yes, I had a question about like the math behind the principles we are using. Are we supposed to be able to explain the math as well, or is it more that we are supposed to understand what happens and explain the principles?
Principles, yes.
Okay. Yeah, that feels good.
But then if I really want to fail somebody, I will ask to show the proof of theorems, of course. But it never happens.
Okay. Yeah. Okay. Thank you.
It's I mean, of course, yes, that's true. That's that is a course, secure artificial intelligence. That assumes that you know a lot of AI and coding for AI. But if you don't, again, so you have this warm-up lab and coding. So I think the main prerequisite, what we assume, is that you can code. That's what we assume, yes. But if not, again, so you see, I just want to remind you that this is a master level course. And if you feel yourself maybe behind in certain aspects, well, again, so it's a matter of spending hours. We all been in this situation, believe me. Natasha.
Yes. No, so I just wanted to add something because for this program, it was not a prerequisite to have any machine learning background.
Yeah.
So for me, especially, I have not done any machine learning before,
Yeah.
so
Yeah.
I read up on all the fundamentals.
Yeah.
But it's still like it's a lot, and it's a lot of math to
Yeah,
learn
yeah,
in just
yeah.
one course.
But I can tell you like this. I understand that. And again, so we learn as you learn. So that's that we should bear in mind. And I mean the idea with this first part, well, no, that's a question. I think it's, but the idea with the first part is to give you a boot camp. So in the rest of the tasks, so it's really, I mean, the rest of the tasks focus on understanding of the article and implementing the concept. So it's less about AI, so to say. It's more about general programming.
Okay. Yeah. Thank you.
Yeah, if I like to add to that. So the assignments overall, also the upcoming ones, like after this lab, it's a lot more programming focused than AI theory focused. So of course, math and such is important for understanding sort of how AI works. But in the end of the day, this is a secure AI course, not the AI fundamentals course. So we will also not quiz you all that much on AI fundamentals. This is more about testing and understanding like attacks and defenses for AI systems. So it largely comes down, for the assignment specifically, it largely comes down to programming, which you have experience in. Hopefully you already have experience in Python, because that would be the language for the whole course. And that's usually not too difficult for most people that have experience in programming. And the nice thing about, as I already sort of hinted at earlier, the nice thing about machine learning with Python is there are a lot of libraries that take away implementing the math yourself. Like if you, when you run the network, like in this assignment here, in part 2, you run ResNet. You don't need to make your own propagation algorithm. You don't need to write your own activation function. You don't even need to choose an activation function to use, because this is all something that's part of the architecture of this model, and you simply use this model from the library, PyTorch, to run your code against it. So you don't need a lot of like fundamental mathematic knowledge to be able to do the programming here. Of course, it's nice if you also learn about these parts, because it gives you a more holistic understanding of what's going on, especially if things don't work as expected, and it's easier to troubleshoot. But just for the assignment, it's not sort of the crux and the main thing that you need to focus on. Focus on the programming part and use the common libraries, PyTorch and such. Please don't use libraries that like do the whole thing for you. If you find a library that does the 1 pixel attack in like 2 lines of code, and you just need to run those lines of code, that's cutting a bit one corner too much. But you don't need to make all the models and such by hand, sort of with like manual functions. In the notebook, here, this notebook for the first task, here it's being done manually. This is not how you will do it for most practical settings. So if you feel like, oh, we need to do this for like every task, like no, you don't need to do this for every task. This is for understanding, to like show you in code what's going on in a model, but this is not how you will be using models for the later tasks and the later assignments.
So this is exactly an example. So when going through this implementation, so you should get kind of a glimpse of what is happening under the hood of the library calls. So, I mean, for example, I uploaded code for this, what was it? This gradient based adversarial example generation. So it uses library calls. So, so in the first part of Lab1, so you see what is happening there. So you see the nature of how gradients appear and such, just by trying to execute this notebook step by step. I mean, so there are stop points created. So that's what's happening under the hood. And hopefully by the end of this lab, you at least have rise yourself to the level sufficient to just use library calls for future labs. Also, maybe, I mean, if I were you, I would use, I mean, for educational purposes, um, uh, like Gen AI functionality for explaining the code. So just to maybe streamline navigation through the code. I mean, it is forbidden to use it to generate the code, but you still can use it for kind of quicker introduction. So what is going on? So I mean, use it. So that's totally feasible.
Okay, then I think we've managed that point. So I was mostly through the actual assignment content anyway, so let's finish that off. Okay, we will use a different audio setup next time to get around these issues that you mentioned. It seems not everyone is having the same issues, but this is also not the most advanced setup, so it might be.
It's lagging a little bit
next time. Okay.
We can verify this right after this session.
Yes. But you can, as long as you can hear what I'm saying, I think it will be okay. So, we were here implementing the tech and answering these basic sort of evaluation questions. These should be answered in your report with some sort of supporting material, like maybe some numbers of experiments you ran, or like some graph of how many attempts were successful and such. And then hopefully you can also talk about it in the assessment if asked. And then task 4, the very last task, we try to implement a defense method against this 1 pixel attack. So we specifically try to block the kinds of attacks we've been doing in the first part, in the first task of part 2. And this itself is based on a separate paper that goes very much in depth for this sort of defense method. So please, once again, you don't need to make this all from scratch. There are the libraries that I'm also like hinting at here that you can use to keep the ResNet 18 that you had from the previous task and make changes to it, because the defense method in question here has 3 core components that you need to have. They do adversarial training, meaning they train specifically on samples that have been manipulated to teach the model, oh, this is what you need to look out for, this is problematic. They add a new layer to the model, which adds pixel-wise attention, so the model can be more aware, so to say, of single pixel changes. So this is actually a step where you need to make some changes to the model. But as I say in the hint here, you don't need to make a new model and train it from scratch. You can use the existing model that you have and make changes through it with the PyTorch library. If you haven't done this before, there's plenty of tutorials online for like how to add a layer or remove a layer and such for a network in Python, in PyTorch. So don't be too scared about this. You don't need to get all mathematical to do the step. And then the third component is just some regularization to balance out any sort of noise and such in the process. But yeah, overall, check the paper. in question, it does go into more detail. You will not get quizzed on like the mathematical stuff or something from the paper. The paper is just there to explain to you what is this defense about, what are the steps that need to be done for it to work, and of course then for the evaluation part of task 4, you can also use the paper for comparison. Like, is your version of the defense as effective as the one in the paper? And then also 2 more general questions. What is the trade-off between security and model accuracy? You will probably see that once you have added your defense to the model, if you run it sort of as normal, like specifying images without any attack happening, it's not as good as it was before you added the defense on top. The defense is sort of making the model work a bit harder, having a bit more, it's not as optimized anymore for pure classification, some reduction in the accuracy of the model. And I want you to think about, okay, what's an acceptable level of trade-off here? Like, how much accuracy can we sacrifice for more security before it just becomes not useful anymore? And then lastly, if you as the attacker, if you change sort of your mental role to the attacker again, you know this defense is being used, can you think of any sort of ways you might be able to get around this? You don't need to implement anything like that. It's just try to think about it. Is there some sort of hole in that defense that you could maybe use as an angle to exploit if you have the options? But it's not like a programming task here. This is just a theory question. And then you're done. That would be all. So I would say go forth and have at it. As I said, the Discord is always online. You can always ask questions in the channel. You will get answers eventually, either from fellow students or from us if someone else answers. And then we see how it goes. If it turns out that it's really too much for the sort of existing knowledge, we might be able to make some adjustments on the assessments as well. So don't like freak out on like Saturday evening because you're like still in part 1. Like, if it's really too much, we'll figure something out. So just try the assignment, use the appropriate libraries, and such, and try to take as much sort of away from the practice part as possible for your own learning. And now we have questions. Farouk.
Yeah, in one pixel attack, the paper says there is a mechanism or algorithm to try more than one pixel at the time to get then bypass it to the model and see the results. Are we going to do the same thing?
No, you don't need to do that. They do that in the paper to like show what the difference is between just changing 1 pixel, changing more. But we only care about this 1 pixel part to demonstrate that even with 1 pixel, you can make a somewhat successful attack. But in the paper, there's several of these parts where they do these comparisons, and you don't need to implement your attack in a way that it can do that even.
Yes, but even with one pixel, you have to try more than one time, right? You can't.
Oh yeah, of course. You might not get the right pixel the first time. Yeah, I meant you don't need to have multiple pixels, but of course you might not get the right single pixel the first time. That's what is being meant here with how many iterations do you need? Like, how many different pixels do you need to test as sort of like your attack pixel, so to say, to get the right result, to get a successful attack. And not every image will be successful. This is not an attack that's like meant for like sort of real use because it's so effective. The paper, I think, if I remember correctly, the paper has about a 2/3 success rate or something like that. It's not like 90% or more of the time that it works in attacking the model. It's just still quite high given the fact that they only change 1 pixel. So that's the part that we're trying to like show you here, that the models, they seem very smart when they classify a bunch of images, like seemingly like people do, but they fall apart also very quickly once you change things in ways they don't expect. And this sort of fragility of the model that like can break very easily, that's what we want to demonstrate. It's not about making like the perfect attack, it's not about making the perfect model, it's about showing that these models seem more stable than they are oftentimes.
Two more questions. For the pixel attack, if we get success on one image, should we apply it for all the data set, or each image has its own dimensions?
So the way this is usually implemented is that you have a small procedure, so a small algorithm that you run over each sample to try and find the best change to make to that image, because it's not going to be the same like sort of pixel position in every image. That's the one you need to change. So you can't just test it on one image, decide, oh, pixel at coordinate like 1520, like XY coordinate 1520 is like the best one. I will just change 1520 on every image to like a different color, and then it works. Like it needs to be changed per image. But
Okay, how many images
write
do
your
we
code in a
have?
way that you don't need to do this like manually every time.
How many images do we
Sorry?
have in the data set?
The data set Cypher 10 has quite I remember not exactly how many it has. You don't need to do it on all the images.
Okay.
You don't need to do it on all the images. It's about getting an overview of like how well it works. So if you like just for developing, like, while you're still making the code, just try it with a few different ones, just so you don't like accidentally optimize your attack for one specific image. If you test it only with one image the whole time, you might accidentally make it in a way that it only works really well for that one image, but it won't work at all for any other images. So that's something called overfitting, actually. It's a machine learning concept that you might have heard before. If you overtrain on one specific element, you're not going to do well on general data. So you don't want to test it on only one image, but you also don't need to test it on the whole data set. Test it with a few while you're making it, and then when you're doing this analysis evaluation part, where you want to get like a percentage and so on, presumably at this point your code is running like sort of more or less by itself, not you doing like every step like by hand, and then you can just run through a couple hundred or 1,000 images. It all depends a bit like how long it takes on your computer. If your computer is like really slow with it, you don't need to sit there for like running it for 10 hours just so you can get like a certain number of images together. Just get like a good bunch so you have some comparison of how well it does overall. You definitely don't need to run the whole data set.
Okay. One more question. Our implementation will be on a new Python code from scratch, I mean.
Yeah, if you want to continue working in the notebooks that you had for the previous one, that's also okay. I mean, the style of these Jupyter notebooks is such that you can run each code block in the notebook by itself. So you can keep it all in one if you want, sort of like have everything in one place. If for your own like organization you rather have it in a separate one, that's fine. But for us it doesn't matter so much, as long as you know which file you need to open when we ask you to show how you solved a certain task. Do we have any more questions?
Yes, I read Evgeny's information from Discord, but will we get any time later? So we know when the time is, because it stands here that it's moved to the afternoon, the 3rd of February.
Yes, so Evgeny intended to also change the official like calendar in time edit, So there it will have the specific time. And apparently
Okay.
he said he already changed it, but apparently it doesn't quite come through. I can recommend from my own experience studying here, sometimes when you have like, if you're importing the calendar from TimeEdit into like your own Google Calendar or something,
Yeah.
depending on how you import it, it might not update it. So you might need to import it again for changes. Or you can check it on the website where you originally got it from for like the most up-to-date version. If it's still wrong there, which maybe it still is, Evgeny will contact the person that's like responsible for these schedule things to make sure it gets updated with the actual time of day as well. But just for
So
your
we're waiting
sort of like
for.
working deadline, you don't need to be done before the weekend, just so you know that already.
Okay, thanks. But we wait for
But we
the
will change it
time,
with
right?
the time of day.
Yeah. Yeah, thanks.
Yes, you will get a specific time in the afternoon where you are sort of, it's your 15-minute block, and it should not overlap with any other courses that you have. We align it for that, so don't worry about that. And yes, the specific time will get published in time, not like on Tuesday, like advance. Mohammed asked about the code files. So we want you to submit your code as well as your report in terms of like explaining what you did and so on. As I said in the beginning, not everyone was here in the beginning, so I'll say it again. For what you want to submit at the end, we also say a little bit about this at the very top of the instructions. You can have this all in one file if you use the notebooks, the Jupyter notebooks. They let you write code and text in one. So you could just write it all in there and then upload that as like one file, and that's totally fine. If you don't like the notebook and you rather work with sort of raw Python files, then you will need to write your report, of course, in a separate document. Just comments in the code are not enough as like a report. Write it in like proper sentences separately if you don't want to use the notebooks, and then you can upload both the PDF of your text and your code.
And the deadline for submission for Lab 1, when is it?
That part at least should have been updated in Commons. If we have a look here, Practice Lab 1, it says
good.
due on 3rd of February, which is the Tuesday night, so after the assessments.
Okay, good.
And
Thanks.
or you can upload it multiple times. So like if you upload it let's say you upload it before the assessment, and then in the assessment we realize, oh, you got that one part wrong, but if you change that one part, you pass anyway. Then you would just fix that one part, upload it again in Canvas, and then you'll be fine. So this is why we don't put a limit on like how many times you can submit files for the assignment. And it also will stay available beyond deadline. The deadline is there to point you at when the assessment is. But you can upload it afterwards if you didn't manage to do it for the assessment, which you should, but it's not going to break. Yes, I think, if I remember correctly, Evgeny did have a rule about point deductions for late submissions. Since the assignments are on a pass or fail basis, this doesn't necessarily have a big impact. But of course, it can make the difference if you were doing super well. Well, if you were doing not remotely well, let's put it like that. So really try to submit it on the day of the assessment and not like a week later. But you also won't fail the course if you submit it later. That's sort of the spectrum here. Any more questions?
We don't have any exam now, but can we do it how to say, re-exam can we resubmit if you don't manage this time and so on?
Yes, so the concepts, yeah, for the re-exam part. So this, as you said, this course doesn't have a formal exam. We have the quizzes and the assignments instead. And both of these have regular deadlines inside the course. And you might get deductions if you don't upload them on time. But at the end of the course, there will be a short period where you're able to make a new attempt at the ones that you've completely failed. If you completely failed any of them, which you will probably be fine if you give it like an honest try. But if you really sort of completely missed one, or you were like sick for the whole week, stuff like that, there will be some time at the end to give it another try. So you don't automatically have to like wait for the course next year or anything like that. We don't want to like make this unnecessarily difficult, so that there will be opportunities towards the end. But please don't tell yourself like, oh, it's fine, I can just do it in the last week anyway, because things will pile up if you do that.
Yeah, exactly. And there might not be time for everyone if everyone piles their work up until the end of the course. So yeah.
Yes. So really stick with these like theory practice week format. There will be some backup at the end, but it's not meant that you just like sort of only focus on the theory weeks and then do all the labs in the last week. Can we download MNIST data in CSV from Kaggle instead of loading it from Keras? So you can. The reason why I said earlier to get it from like the library is that it just saves you time, and you will probably want that time for working on the harder parts of the assignment. But if you just love playing around with data, sure, you can get the data from other sources. Just make sure that you got it like from like a proper. I mean, Kaggle is quite reliable, but like if you're getting the data from anywhere else in general, make sure you got like a proper version of the data set. If it's sort of like messed up, or like the images are all like in a weird format and then your code doesn't work because of that, that's your problem. Because there is an easier way, which is just taking the model and the data set from the libraries like PyTorch, TorchVision, and so on. You will also find these libraries if you Google for them. They're like very popular. It shows up very quickly on a Google search. So that's just the easier way to do it that we recommend. But as long as you have the right data set and you do the right work on it, you're fine.
Hey Tim, I have a question regarding the grouping. Did you created the groups yet? Because I can see I'm still like I created my own group, and I think you would remove that because I just created before starting the session. So I didn't know that this time you will arrange us into the groups.
You mean a group for working on the assignment, or you mean for the assessment specifically?
The assignments.
Yes, so for the assignments you can make your own groups. Like for working on it, you have your working groups of 4 to like share the workload, and you can form these groups yourself. So you can just pick some other people from the course. If you don't know anyone in person, you can also go to the Discord server and write in the general chat like, hey, does anyone still need a group? And then try to find some people to work together, because it will be a lot of work if you do them alone. And then there will be these randomly assigned groups only for the assessment, only for these oral sessions on the Tuesdays. And they're separate from your normal group. You will have 2 groups in that sense.
Okay, got it. Thank you.
Oh.
Can you go back to the assignment instructions? Yeah. Task number 1, please. So here, yes, number 1, this is what we are going to follow to solve our assignment, right?
To follow the first.
Yes.
This is just for the first one.
Yes.
Yeah, if you look at the tutorial, I think I still have it open. Yes, here it is. So this is this is like a tutorial published by someone else that we found to be quite good and comprehensive. So especially in this, like further down here, it has this section about pre-processing. And when we talk about doing the steps of the tutorial, performing all the pre-processing steps for your dataset, we mean the steps here in this tutorial.
But in this case,
tutorial shows you what these are supposed to do, and they also give you some like code examples how to do this. You're supposed to do this for the dataset that Evgeny selected for that task, which is MNIST.
Which including the converting part.
Where's the conversion part again?
I think it's mentioned
What do you
something
mean
about
with the converting part.
Yeah, I think we are going to convert from unit A to float 32.
Yeah, Control F, maybe just Tim.
Float. I mean, this rescaling here, or?
Yes.
The float here is just so the calculation runs properly. I'm not sure if this is actually the part you meant. So some of the steps, so this is a general tutorial for pre-processing. Maybe it might be that some of the steps are already unnecessary. Like for example, there is a part about rescaling and resizing to make sure all the images have like the same size. And if you download the dataset from like any sort of decent source, they will already have like a unified like aspect ratio, for example. So then, of course, if it's already in the right shape, you don't need to reshape it. But the other parts, please do. Also, the whitening. You will not. I mean, this is not necessarily about, training the model in like the best possible way. It's like trying out a bunch of different techniques from pre-processing that can be useful for machine learning in general. So that's why you're supposed to try all of them, even if some of them might seem like unnecessary or like not relevant for the training of the model like later on. And yeah, in here, in the tutorial, they use another data set, namely the one that we use in part 2 for the 1 pixel tag. So this is the only thing that you're supposed to do different from the tutorial. You're supposed to do it with the data set that's described in the assignment, the MNIST data set, not the data set in the tutorial. Just do the same steps as they do on this data set, on MNIST. But it should work just as well on that one, since it's all images either way. Any more confusion about that part? Oh yeah, sorry, Daniel, one moment. We just saw that someone also asked in chat earlier about groups of 2. No, I think this got messed up a bit during the initial week of the course when we were deciding how to do the assessments still. So it's groups of 4 for both kinds of groups. You work in groups of 4 for completing the assignment, and then you also get tested in groups of 4, mainly because if we do smaller groups, then we won't have enough time in the day to do everyone. But it's group of 4 either way. And yeah, for the groups, when you work on stuff, you can choose your own groups, and the other groups for assessment, are randomly selected.
Mm,
Put that clear again.
Last week we were specifically told that it's changed from 4 to 2, and it was, I think, written somewhere also.
Yes, unfortunately, we had some discussions with Evgeny about the labs, where he thought it might be too easy, sort of, if you do group of 4, and we found out that most of you don't actually have AI experience, and then we realized it will not be too easy in groups of 4, so we put it back to 4. We should have checked this in advance, so this is on us for like causing the confusion. But now you have groups of 4 again to have more room to work on this.
Are we allowed to be 4 now?
4, yes. I will post another announcement with Evgeny that to confirm that it's 4, not 2, just to make
Yes,
sure everybody is
please.
aware.
Yeah, because it's been like 2 and 4 all the time, so it's really hard to keep track.
Yes, and I know I had this before as well when I was studying here, that the courses that are like a new course tends to be a bit messy, unfortunately, and it's not nice for you guys, but we will try to fix things as we go to make sure it's not unreasonable for you to complete the course.
But we appreciate that we can be 4 anyway, so it's good. It's better to have maybe a better, less workload and more like discussion and stuff, so we can fill in
Yes.
because we missed
Yeah,
the AI
definitely.
part. So yeah.
Yes. Use the discussion, use the Discord chat, talk to the other groups as well. Like you are working in groups of 4 for like your report, but if you want to like meet up with 50 of you and sit in the same room to like discuss how to solve part 2, you can do that. just the report has to be like done in groups of 4. But for like figuring out what to do, feel free to talk to each other from all the groups, all the students. Just don't like fully copy each other's code between all the groups.
And make sure you understand everything individually. That's the important takeaway.
No question about the generative AI. It was forbidden to use it, but it's good to use it because by learning. But for example, like me, I just done a Python programming course before, but I'm not that super good at Python. So how do I manage this course? I think just about a bit.
So I can tell you, Python coding for machine learning is not advanced Python. It's because you use a lot of libraries for most of the stuff. You rarely need to do sort of like fancy algorithms or complicated in terms of programming in when you do machine learning stuff in Python. It's quite streamlined thanks to all the libraries that are available. So don't be sort of scared if you don't have that much Python experience. You don't need to be like a senior Python developer to be able to do this. And when it comes to the AI coding, as I said earlier as well, before I think Evgeny missed that part because he joined a bit late. He had meetings. But as I said in the beginning as well, I personally don't recommend using AI for stuff that you don't know yourself yet, because when it gets something wrong, you don't know that it's getting it wrong, and now you think it's this way as well, which happens to be wrong. So that's, I think, the big risk of learning things through AI, through generative AI, that you can easily get like misled by the model, because the model doesn't know shit really. Like the model is just a very good parrot for data. But of course, it is quite useful to do things more quickly. So, and also, we can't police you doing your stuff on your own computer. So, do the workflow as you like. But if you use AI stuff, please make sure that you understand what you have written. Don't just like make ChatGPT generate like this much of like text or code and just plug it into your report. because you will not actually know line by line what's going on. But
Yeah,
if you want
the
like to use it to
sorry.
ask it, hey, what does this code do? Or what library should I use to solve this? Like these are all like really good things to use it for, because it's also like quite simple questions for machine learning stuff, which are less likely to get completely fucked up by the AI. That's at least a good thing, that since we're not expecting like a super high level of machine learning here, the entry level stuff is usually better quality in the LLM responses than high level stuff. I hope that clears it up.
Yeah, it's like I always do. I try to understand what I'm doing, even if I'm not the perfect one with Python. So
Yes. As I said, also when it comes to the performance of like you running your model or you're running your attack and you notice, oh, it's not doing so well. Like if it's like 10, 20%, 30% worse than like the model in the paper is in terms of like accuracy and so on, it's not gonna fail you the assignment. It doesn't need to be like the best model ever. It should be better than like raw guessing. Like if a classifier gets like, if there's like a true or false thing that the classifier needs to answer and you get it like wrong 80% of the time, then you fucked up somehow. But if your model is performing like somewhat well, like better than guessing, and you've done like the steps that you algorithm and you can talk a bit about why you did it like this, you will be fine. It doesn't need to be like the best model ever. So don't stress too much about like optimizing or doing like sort of high level like advanced stuff to make it faster or something like that. It's not required here at all.
So, if I may ask, when will you guys submit that we can be forced, so that we can start work, plan the work with the other group?
Which group do you mean now? Because the working groups you can choose by yourself. You don't need to wait for us for that.
So we can be four now, and we can start working as 4 people in a group.
Yes. Can
I
start right
think I
away.
understand you that
You can
you're gonna
choose
post
your
something
own.
on Discord as well.
No, I wanted to post it again because not everyone in the course that is registered is right here. Because over 100 people are registered in Canvas, but only 30 people are in this meeting right now. So I will post it again, so I don't have to answer this
Perfect.
question like 10 more times.
Yeah, thank you.
That's what I meant.
Yeah,
But like,
yeah,
you're
okay,
good to go.
perfect. Yeah, good, thanks.
Yeah. Any more questions? I think we're coming up to the end of the time slot probably anyway. I'm not sure if it's officially till 45 or till 12, but
I think it's 45 or
but I mean anyway, so if you have any more questions, you can stick around. I will sit here for like another 2 minutes or something in case someone comes up with something. Otherwise, have some lunch, have a look at the assignment, find some friends or buddies in the Discord to form the group with to work on, and then let us know on the Discord channels like if you have trouble, and we'll sort it out.
Thank you.
We end at 11:45, right? So is it?
Yeah, official end is 45. I'm just gonna let it, like, you can leave. If you have no more questions, you can go. I'm just leaving this on for like a couple, like 2-3 minutes in case someone still has like some questions. So some people only joined like 10 minutes ago.
Okay. Yep. Thanks a lot for the session.
But yeah, if you know everything, you're good to go. Have some lunch. Take a break. Yes, we're mute on purpose. Yes. This is it then for today. I was muted because I was just talking to once. Since we're just waiting in case someone has questions. But now we're also on time for it to finish, and most people have left as well. So we'll go now, and then yeah, see you on the Discord if you come up with more issues as you try the assignment. Goodbye.
Yeah, goodbye.